So we left on just generally pass by value, I think.
Hmm.
We have three functions and I was trying to edit them. I'm not sure if that worked. So we'll see here. I think I wrote the functions but didn't actually use them. So let's just go ahead and start with calling this top function here, pass by value for print. So we have a string and we're going to pass in just a value. This is pass a value, so we should be returning about picking that guy in. Where's string value? I think I want to do a full return here. We're gonna, I don't know what I have there, so I'm just gonna start. I'm gonna comment all this out. It's been a couple weeks. Maybe it's star star. Are you trying to remember C++ syntax here? That multi-line comment is not. I think I have an extra. All right, whatever. We'll press with this. I'll just edit the functions. Okay, so we want to demonstrate a pass by value function. I think I wanted to do it with add. So what I'm just going to do is comment each of these out and do a little add function instead. Just so that fresh and clean. Let's come back here and let's do an add function. So we're going to return an int. I'm going to do an add function, add path, just to be clear. Return. Here in a second. We're going to do add int a, int b. We're going to do c equals b. And let's return c. Semicolon. All right, good to go. All right, now let's demonstrate that. Do int num equals value 2 close b out b and l. So double check that everything is in here. What did I fail to compile? Clean. Thanks. Let me see. Maybe it's supposed to be. I don't know why I did that. Anyways, I must have been smoking crack or something when I wrote that. All right, so we have our main function. We're running. It's num equals add pass by value. So what's happening here is the values here are, and this is actually better expressed if I make the variables val1 equals 1, and I do it again. 2 equals 2. It's better expressed this way for the other examples. Do that. Okay, so the arguments are these values. These values are literally on the stack. You know, variable on stack, variable on stack, which means it's a value at a memory address on stack. And then we have pass by value function. These don't specify a reference or a pointer. Therefore, this is a copy, sometimes also called pass by copy. So what's literally happening here is that in the stack, in this add pass by value function, it is literally copying the variable that's in one memory address to another address that represents the argument. There's a copy from here to here. It's not actually passing that memory address. It's copying it here to here. How can we demonstrate this? How best can we demonstrate this? So if I demonstrate. So it's returning C. Let's just do a simple pass by value where we pass in. This will be very simple. Where we pass in A instead. Okay, and we're just going to return A. But we're going to do something to it before we return it. We say A equals. That just means that's the equivalent, by the way, in C++. A equals A plus 1. If you remember when we were doing that.
Yeah.
So we're just adding 1 to it. And let me fix this real quick. This is the downside of not getting paid lessons. I don't prep ahead of time.
Okay.
So we passed it in, we added it, right? So now, if I see out, I want to do this STD, and I want to see out value, and I want to see out now. Show you what so they're both. So this is one. One of these should not be that here, and one should be explicit. Maybe reasons. Oh, maybe plus plus didn't do that. Oh, it's just A plus plus. It's not A equals A plus plus. It's a different aspiration. Okay, so all right. So I think I could also do this way. Well, there we go. That was dumb. I don't know what I was doing beforehand. Okay, so as you can see, this is a copy. It's not the original value here because value is still 1 and number is no longer 1.
Got it.
Now let's demonstrate pass by reference. Return the reference though.
You still have pass by value in the function, right?
That's a good call. Maybe I don't. In a while since I've done this in CQ. Boom. Okay, yeah. So they're the same value because value, the memory address, the actual variable was passed into the function, not a copy.
I see.
And so we changed it and we just returned the same thing. So num and value are actually the same reference. They're the same memory address. And so it's exactly the same. And similar to pass by pointer, you don't do pass by pointer a whole lot, but I'll show you. I think I do return. Might have to dereference it to get to that point. I think this is the result. Oh no, I didn't. Okay. I didn't do pass by pointer. It was overloaded to pass by. Be close. Pointer. Boom. Okay, yeah, I knew I was going to get syntax error. No. Where's it actually at? Right here. So
You have to
this
do the
has to be a
star.
pointer. Yeah, this has to be a pointer. Is new. How do we do this with an integer? Here. Create a pointer. I'm creating the pointer technically on a stack because it's not a new.
Mhm.
This might be a good ChatGPT moment. New. And how do I? Here. Five increment x equals x plus one int main pass in five incremented by one. Special pointers. We have a pointer. Oh, so you have to grab the memory address if you're going to do it on a stack. So if I'm going to do this an integer, which is primitive, which usually lives on the stack, if I'm going to do this way, I have to grab the memory address. So I have to use the reference signal to grab the memory address. I think yeah, you might be right.
That's what I had on that one for both the return and that it had stars.
A value star and cannot be initialized. Okay, hold on. So this has int on the stack, and then it says pass the address of A. Now I grab the address of A. Good. This just doesn't return a data error.
Mm.
So maybe I have to. There we go.
Boom.
Yeah.
Boom.
Boom. So we're returning a pointer. That was okay. So now if I do my situation, I get the memory address, which is good. That meant I returned the pointer. If I dereference it, ooh, dereference. It's
Is that an
something.
integer or memory address?
I forgot to dereference it here. That's where it's happening. So that is a piece of basically memory. This is what's weird about C++, is if you like add stuff or do things to a memory address, it changes the memory address,
Mm-hmm.
not the variable. I had to dereference it in the function in order for it to change the variable. It didn't work. Did I save it? I might not have saved it. Did save it up. We return a pointer and it dereference the pointer and the value. Check this memory address. Why is that value so low? That I'm doing it somewhere else. I know I am. So I'm going to say, I'm going to do this. Something's wrong in this right here. I think they're maybe C++ automatically dereferences for the plus plus. So here's where you just start to get into debugging real quick. I'm going to print out. It's a star there. So print. Each time was the first time was the address. The second one was one. Okay. A want to edit the value though. Do this. Does it yell at me? No, it doesn't. Okay, so that was it. Maybe star plus plus doesn't happen because it's like concatenating this function, so you have to like spell it out if you're going to use pointers, which you don't usually use for this. Either dereference it twice. Force the value. All right, and now we return the pointer. So the point still stands that because I passed in a pointer, which is the actual memory address, and I returned that pointer back and then sent it, I've now affected the memory of the pointer. Now, the point of why this matters is, and why this is really why you have like pass by reference even as a thing and pass by pointer, because sometimes you want to make a copy of something
Hmm.
and you want to edit it, and then you maybe want to return it, but you want it to be totally different piece of memory because you want to reserve the original memory that's here.
Sure.
You don't want that to go away. Sometimes you want to do pass by reference where you want to pass in basically a pointer, but you want it to be passed in as a reference so that you can't change the memory that's pointing to within the context of the function. So, in this second example of pass by reference, we didn't do this, but I'll give you an example. Pass by, correct. Need that anymore. Believe I need to make this clearer. And that's just uncons qualified cannot be initialized by a pointer. Okay, so I have to make so sometimes it's like I want to edit what am I trying to show? I'm trying to show why you would use the reference because obviously like the reference is a pointer that can't be changed in terms of its memory address. This won't work.
Well, it seems to me like my read on it is that the pass by value, that was the one where you had two different numbers, correct, on the output.
Yeah.
So
that's true.
And then
you're gonna have two different numbers. Yeah.
The pass by reference changed both the numbers, correct?
Correct. It actually is the same number though.
Yeah. So
it's the same end memory address that was basically returned. Yeah.
So if you had like a simulation or something and you wanted to constantly update, you'd use like a pass by value type function, right? But if you had part of your simulation where you wanted to keep like, I don't know, maybe the first time step, then you could use like a pass by reference. Is that what this is getting at? Where you could always
the meta theme is that pass by value is only used if you want to make a copy and don't want to change the original variable. That's outside the scope of the function.
Okay.
So like this variable, if I didn't want to change value, but I wanted to like mess around with something else and return a num, like I needed to use value elsewhere and I needed to stay the same, then I would pass by value. Because then I would make a copy of value within the function and return back something else. Anytime you pass by reference or pointer, it's because you want to manipulate value itself.
Got it.
This is essentially val. This is the same thing as val and a pass by reference or pass.
Sure. I see.
Point. Yep. The other thing I was trying to show you is why you would use pass by reference over pass by pointer. So I was going to actually ask ChatGPT for us. Why would you use pass by value or pass by reference instead of pass by pointer? Yeah, there's a bug in my code. or dynamically allocate. I want the meta theme though. Use references. Use pointers when you want the argument to be optional. Null pointer, which you don't know what that is. Could be working with arrays and dynamic memory, or you need to reassign a pointer inside the function. So that's like a one key theme is if you need to change that pointer to point to a different piece of memory address in the function, then you would use a pointer. You're working with arrays and dynamic memory. This can get really complicated really fast because I haven't taught you about data structures yet, which maybe is actually a good lesson to go into at some point. Just not today. We don't have enough time. But you can essentially, what I'm showing you is a very dumbed down version of like how you would use pass by pointer and pass by reference. But I haven't taught you about arrays and vectors and lists, which are represented in memory differently. They're represented as pointers and references, but they're like, data structures of a bunch of, a bunch of values together essentially. You can have like linked lists where they're disparate in memory and you like basically like jump around. There's arrays, which are sequential in memory, meaning it's like each like bit is in order. And so if I have like 1, 2, 3, 4, 5 in a list, then I know that the fourth element is 4 every time. And then there's vectors, which are basically, you can think of them as arrays, but they can grow in size where arrays can't grow in size. I haven't taught you about that yet. That actually might be a good lesson next time because that gets up to the point of when you would use these. But for the purpose of this, to fix it and close it out, pass by reference. So I have to make a pointer of a new int on the stack or on the heap. So I would need to do val equals new int. Check this. It's not right. And does this work? So number equals 1. We're basically grabbing that's on the stack right there. This is grabbing the memory address on the stack, assigning it to the pointer, to a pointer that's pointing, it's on the stack, but it's pointing to another address on the stack. And then not even making it a pointer, they're literally just passing in actually that. Yeah, okay. I thought you had to have it as a memory address, but I guess you don't. Because everything, even values, have memory addresses. It's just whether you're actually like setting a variable to set the point to the memory address or not. So this is passing in value on the stack as a reference to A. So if this, when we compile this, we should get 2 2s essentially. So 2 2s. Because it just changed the value of value within the function. And then it returned value, even though I've named it a different name on the stack, it's still value. And value prints twice. Does that make sense from a reference standpoint?
Yeah, I'm tracking.
Cool. So this is essentially it when you're just looking at like variables and functions. You use this when you want to keep original variable that is passed in the same. And then use this when you want to the original variable. And the same with pointer. I would say affect the original variable and you want to potentially reassign the pointer to point to a different chunk of memory in the function. That's essentially why you would use each of these without talking about data structures at all.
Yeah.
All right. We made it through, dude.
Cool.